Guys, today I have a, I think it's 2010 Chevy Malibu. I have a couple trouble codes here. This is just a generic OBD2. I have a oxygen sensor, bank 1, sensor 2 heater control. Also bank 1, sensor 1 heater circuit. Then I have a sensor, sorry, bank 1, sensor 1, no activity detected. By looking at the current data, now this is a 3.8 liter engine, but problem with these, it's a V6 engine, but you got only one sensor, one upstream and one downstream. You don't know what individual heads, what kind of fuel mixture you have. You can see that the bank 1, sensor 1, it's around half a volt, the same as on the downstream. So upstream and downstream are pretty much at the bias voltage, but this tells us that our signal wire is okay, but there are no activities on any of these sensors. Now, this being a code for both sensors, we need to look at the power feed to our heater elements. So the heater circuit is here, and there's a downstream, there's an upstream sensor. So you can see that we are getting both of these sensors getting power from this fuse here, oxygen sensor, 15 amp. It's a in the fuse under the hood. And let's find this fuse and check the power first. Okay, my fuse is here. The bottom fuse on the right. I'm gonna make the battery ground, or just the battery I think is in front actually, so I'm just connecting to the ground. And let's see here. Good. Good. Okay, so the power feed is okay. Make sure I'm in the correct. Yeah, it says oxygen sensor. Okay, so let's see here. Alright, now on the sensor itself, there are two black wires in this one. One should have power. Let's see here. Okay, I got a power. Okay. Let's see, now the other one should be ground. That should be controlled by the power control module. I'm going to connect my test light to battery positive. So we got the power and a ground. Okay, that's weird. Why would the computer flag the code for heating circuit if it works? I'll take the amp clamp and put around the put on 2 amps setting. So DC. Alright, to zero it. Let's see, I'm kind of confused here. Top 2 wires. If I put my amp clamp through the wire, that should, when it's heating circuit, I should have a current. And I have a current of 1/2 amp on the upstream sensor. That's weird. Why? Okay. Alright, you see it's comes and goes. Now what I'm going to do next, I'm going to check the current on the downstream sensor, but instead of going down to the sensor itself, I'm just going to put my fuse loop here And we should measure 1 amp here, you know, so half an amp on upstream and half on downstream. We should have a current around 1 amp on this fuse now. Take it out. Okay, so this is not my fuse. Okay. That's weird. And that should take my current. Okay. Unless my covers are switched. How about that? All right. That's interesting. Oh, that's better. So I wasn't completely wrong. Well, okay, so now. Okay, so my fuse is actually this one down at the bottom. Okay, all right. That makes sense. So basically the same fuse, top, bottom right, but on the bottom fuse box, not the top. These covers were switched, and I'm looking at the, it says oxygen sensor, but it was on the top. So, that's interesting. So, anyhow, now this fuse should not be blown anyway, since we have a current on the upstream sensor. Let's check this again now. Alright, here we good. Here we good. Nice. Okay. Well, let's take the pull this fuse out now. That should kill this circuit here, and it does. Okay. Now I'm going to install the fuse loop, and I have actually 15 amp circuit breaker. Every time I'm dealing with stuff like this, I actually keep my circuit breaker in this loop now all the time. You know, just if I have any kind of electrical problem, instead of popping the fuses, this works perfect. Alright, so let's put this in. And we have a half a volt back on our heating circuit on bank 1. So now technically we should have 1 amp combined upstream and downstream sensor. And we do not. Okay, so our problem is the downstream sensor. Alright, time to get under. So basically what I've done with this test, I hope you guys understood what I was talking about. I'm checking a current on the upstream O2 sensor. I see the half a volt, that's normal. I'm happy with that. So now if I have a, if my heating element, if my heating circuit is completed on downstream sensor, we should have, because this fuse feeds upstream and downstream sensor, we should have a 1 amp of current for both sensors, and we only could see, when I put my fuse loop here, you could only see actually current that we already seen on the bank 1. I'm sorry, on the upstream sensor. Okay, so it's going to go down and check the sensor, downstream sensor. Here's my main harness. It goes into the oxygen sensor. I don't see any damage on the wires. the harness, the oxygen sensor wiring was not laying on the exhaust, so that's good. So let's go ahead and put the M clamp around these this wire here, and so there's two browns. It could be two black or two whites, doesn't matter. It actually matters, but those like you're always going to have two wires the same color on the sensor harness, and that's going to be your heating circuit. Let's go ahead and get the M clamp around. So I don't expect to see current on this wire at all. Okay, let's do this. Got nothing. Okay, so the next step we're gonna take, I'm just gonna pierce the wiring. I'm pretty sure I got a bad sensor anyway, and we're gonna check the voltage coming to the these two wires. You know, we should have a power and ground. Of course, the ground's gonna vary because the computer controls the heating circuit, and if that's okay, we're gonna need a sensor. My next step was to pierce the wires on a sensor side, and just to look at the voltage, to start the car, look at the voltage. If I would have a voltage, you know, power from a fuse and ground from the power control module, pretty much we need another sensor. And I'm glad I did not do that. And when I look at the harness itself, look at how there's only one wire actually. This female connector is sticking out. The other three is actually pushed in for some reason, and I'm not sure. This is the purple wire. Could be a signal wire or a ground. Most likely it would be signal wire. Anyhow, I need to get this open and see if I can push these pins back all the way to the end of the connector. In the meantime, let's go ahead and check the resistance on this heating element, and then we try to get this fixed. So I got my these small probes hooked to my heating element. You can see there's two brown wires, and we're looking at the ohm meter, and we have a 14.4 volts. So there's nothing wrong with this heating element other than connectors are messed up. I'm gonna get this taken care of, and then also unfortunately the this connector is here broken. This is from the harness side, but I think still works okay. You can still lock into place, of course, and then moisture can get in it, but so far it's been dry. Now I'm gonna take this fuse out, one that feeds both of the upstream and downstream heating circuit, and we're gonna put the our fuse body again. And if everything works now, we should have a 1 amp of current from both heating elements. Fuse out. Got 0.7. Now it depends how much the computer is energizing the circuit. Let's see what we got on this one. So nothing on this one now. This is interesting now. We don't have a current going through the upstream sensor, and we got current going from the downstream sensor. Because right now, when I put my clamp on the upstream sensor, I got no current. Explain why do we have two trouble code, the upstream and downstream heating element circuit, and also we have a code for a signal on the bank 1 sensor. So I'm trying to take care of the heating circuits right now. Now, is it possible the computer is not, or is it possible that I'm on the wrong wire? That could be, no, 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 it's on the good wire. Not good. Okay, now the computer is telling us 0.6. Okay, so let's say if we have around what's going on here, 0.6 again. Okay, there you go, 1.2 amps. Good. So this is what I wanted to say the first time. We got 1.2 amps of current. This tells me that, I'm not sure if you guys can see that or not. We have a 1. See, it's actually, computer is actually, it looks like turning on and off the upstream, you know, but you can see we got a 1.1 amp of current. Now this tells me the wiring is okay on downstream sensor as well. And now I'm going to go to the scan tool and see if our downstream sensor is working. Okay, so downstream sensor is doing something. It's no longer on a bias voltage as it was before, so it's working. So that's good. Now we still have a problem with the upstream. Where's the bank 1 sensor 1, it's still on the bias voltage. We still don't have activity on this sensor at all. So this explains our other code for the signal circuit on the sensor 1. So definitely we are fixed with the downstream sensor. Now we do know that our heating element is working okay on the on this circuit. We pretty much know that our signal wire is okay because this is a bias voltage. All we gotta do is actually check the ground on the sensor side, and if that's okay, we're gonna need a new sensor on bank 1. I'm sorry, I kept saying bank 1, it's only one sensor, upstream sensor. This bias voltage tells us we have a good wiring. If we have a good ground on the upstream sensor, we need a new sensor here. Voltmeter, I'm gonna put my negative lead to ground. And check the meter and the volts DC. Nope. Okay. Check the ground again. Nope. Something's not right with my meter. I'm going to change this plan. Still nothing. Okay. I'll change this pin. Needle. Backdoor pin. Okay, there you go. My pin was not working. let's go ahead and check. Now we can actually, on this pink wire I should have battery voltage. That's my heating circuit. We already know that works, but I think my leads are messed up. There you go. So 14.2 volts, and on this one we should have a variable voltage from the, now it's full ground at this point, from the PCM. You can see how this voltage varies from the power control module. It's 0.5, see that's how, you know, controls the current through the heating element. And this can mess you up, you know, if the computer has an active code, it may not even bother to activate the heating element. Alright, so the other two wires, one's going to be the signal, one's going to be the ground. I think the black one should be ground. 72 millivolts, that's okay. And then this should be our bias voltage, 400. Okay, this one is 630 millivolts. Okay. Now, so this other wire, if I connect my test lead to battery positive, and I touch this wire here, the black one, that should be ground, and it should light up. So I have a good ground on my I already verified that with the meter, but it's okay, we can use the test light as well, as long as our circuit is loaded. Anyhow, ground is good. Our sensor wire, we can, let's go ahead and unplug the sensor now. See, 450 millivolts, that's our bias voltage. We're pretty much done. Nothing else we need to do. We need to put the sensor in this, we're going to put this upstream sensor. Yeah, there's something else we can do since I'm already on my signal wire. There's my upstream sensor. You can see it's a 400 millivolts, 460, and that pretty much tells us that wiring is okay. But we can do on our meter. So now I'm connected straight to my signal wire. The sensor is unplugged. If we move this meter to diode mode, we're going to feed 2 volts to our circuit, 2.5 volts. This is what the meter is doing. And to check the diodes, we can see right away that our voltage went to 1.1 volt. It tells me that wiring is fine. It's a pretty quick, easy test, safe. Just switch your meter to diode mode. This Fluke meter works off of 2.5 volts, like a snap-on works off of 5 volts, but quick and easy test. We verify the wires go back to voltage. It's going to drop down back to our bias voltage of 460 millivolts. And we now know that our ground is good, our heating circuit is fine, signal wire is okay, all the way up to the computer. We need this new sensor on this upstream sensor. Got the sensor in, and I actually did check the male and female connector on this. So this one is actually on this sensor side, on the upstream is actually male, on downstream is a female, and one on the harness side is fine as well. So that should be okay. Now, one thing I actually didn't mention when I was doing my amperage measurements on this fuse here, you want to make sure there's nothing else is actually fed by this fuse. And I checked my power distribution, and this fuse only gives the power to upstream and downstream sensor. Now, if this fuse gives the power to other components, and most of the time you have actually like 4 sensors going, but you can actually combine amperage and you should see that as well. So it's not, but if you just want to make sure that if the other components are fed by this fuse, you wanna don't get confused, because you're gonna have a different in amperage. But you can see we had a single like 0.5, 0.6, 1 amp at some point, and then with a second heating circuit on downstream, they went up to 1.2 amps, and that was okay. And then pay attention to your codes, because you know we had fixed a, so I'm not exactly sure at some, you know, why it was flagging the code for the upstream heating circuit, because looks that was okay. unless it was intermittent, I'm not sure. But at some point the amperage was dropping down, maybe that I didn't actually check the voltage. I didn't know if the computer is actually closing the circuit or not. So just because you see a 0 amps, it doesn't mean that, you know, you have some problem with the sensor or the wiring issue. You have to check your voltage, make sure the computer is actually energizing the your circuit, and or whatever needs to. Is it a switch or relay, anything? You know, you got to make sure that you got a voltage as well if you have 0 amps, if you don't have a current. I hope this doesn't confuse you guys. And anyhow, the sensor is in, and then of course we had a code for a upstream signal where then we check our current. We already knew that our heating element is okay, the heating circuit was okay. We checked our ground. I was just repeating myself. And then of course checking the signal wire. Now also something else I need to make sure you guys understand. When I was checking my signal wire integrity, and we turn our meter to a diode mode, and I said that the meter is using 2.5 volts, but we could only see like 1.1 or 1.2 volts on a signal wire at the computer. Meter is using 2.5 volts for sure, but on the oxygen sensor circuits, on the narrow band circuits, you're only going to see that threshold of 1.2 volts. Even if you put 10 volts into the circuit or 15 volts, even if you're short to power, you're still going to see only 1.2 volts. That's actually what the computer is programmed to. It's gonna give you that measurement, basically that signal on the PID is gonna be only at 1.2 volts. And anyhow, let's start it up and then see what's, you know, if you're gonna get our signal back on our upstream sensor. That'll see what's already working once we fixed our after we fix our heating circuit. I'm sorry. Now, you already see that our upstream sensor is alive. It's already switching, it's nice. And we need to look at the fuel trim. Let's go ahead and customize it. Now, even though this is a V6 engine, since you got only one sensor, just gonna have one short term on bank 1 only. This is nothing. Oh, I should get a loop status. Okay, the fuel trim looks pretty good. Minus, yeah, it's nice. I was kind of worried how the engine is gonna run, if you're gonna have any other problems with our fuel trim, since sensor wasn't working correctly. Now all of a sudden our downstream went to 0. That's interesting. The upstream looks great. Maybe it was upstream switching nicely. It's pretty good. I'm not sure what to do with the downstream now. Looks like we're going to need a downstream sensor as well. Maybe it's not warmed up yet. Okay, it's waking up. Looks like it was not warmed up all the way. But yeah, it's working now. Well, unfortunately, we're going to have another code because our catalytic converter is completely shut. You can see that our downstream sensor pretty much mirrors the upstream, and that's not good. It's like looking nothing. There's nothing's happening inside the catalytic converter. And pretty soon we're going to have a code. Yeah, that's not good. It's not the same frequency, but it's like 50%, which is, it shouldn't be like that. And unfortunately, we're going to have another light. Now, why this happened? Because due to the fact that computer could not do a oxygen sensor, it may not be. It's actually, maybe this needs warmed up. It might be okay. I don't know. It's dropping again. It might be okay. We just need it warmed up. Well, this is confirmed fix. The fuel trim now, the long term is going to -10, and you got 3 or 4. They're creeping up on the negative, but I mean it's not terrible. I'm just gonna. This car needs. It's been sitting for a long time, so this car needs to be driven, and they had these oxygen codes forever. The computer needs to learn the fuel trim and all that. So what I'm going to do next, I'm going to clear the codes, and so we'll see if we can clear all that. See here. Just start it up. Engine runs pretty good. I mean, it's here. No codes. That's good. Okay, long term now. The bank one is positive 11 and negative 8. And short term, we're fine here. That's okay. I'm happy with it, with the fuel trim. Now let's just go look at the sensor again. I just need to take it for the test drive, and the computer has to do all the monitoring and everything, but monitors. But the oxygen sensor still works okay. Fuel trim here. Yeah, you're fine. Look at this. 1.12%, -4. Perfect. I'm happy with this. Alright, there's nothing else to it. It's still working. It's okay. Again, are we going to have a code for catalytic converter? That's the P0420 most likely, but that's nothing I can do about that. Definitely it's not looking good on the downstream sensor at all. Yeah, pretty much now mirrors the upstream. Yeah, the cat is tossed, but it is what it is. We fixed the codes that we had, and we're gonna move to the next one. Anyhow, it was kind of interesting just to see that you always make sure that you check your connectors. That you don't have a problem there. And sure enough, this one's kind of weird that 3 of the female connectors are pushed further into the connector. I have no idea why. There were no corrosions or anything, so while I pushed them back in, it the sensor and the heating circuit went back to life again, and then we checked the upstream and downstream and all that 9 yards. And now once we fixed the heating element circuits, and then we went to went back to a sensor, upstream sensor, to figure out why we don't have any signal. We already knew that our heating circuit is working. Check the ground good. Check the signal wire, and everything's good. I put a new sensor and it works fine. Alright guys, thank you for watching, and see you next time. Thank you. Bye bye.